In this module, you will learn about thrust and pressure. Thrust is force acting on an object perpendicular to its surface and is denoted by F. For example, consider the simple act of driving a nail into a wall with a hammer. The force that you exert on the hammer during this activity is thrust. Thrust is measured in Newton, denoted by N in the SI system. Nails have pointed tips to help us drive them into surfaces. Why is it important for a nail to have a pointed tip? And why is it important to have a sharp knife to chop vegetables? The effect of the force you apply in driving a nail or chopping vegetables is translated into pressure. In other words, pressure is the amount of thrust acting per unit area. Pressure is denoted by the letter P. Hence, pressure is calculated by dividing thrust by area. The lesser the surface area of an object, the more the pressure applied by that object. The pointed tip of the nail minimizes the surface area of the nail on which thrust is applied. Therefore, while driving the nail into the wall, the pressure on the pointed tip of the nail is more due to thrust applied by the hammer, which helps to drive the nail into the wall. Pressure is measured in Newton per meter square, or Pascal, denoted by PA in the SI system. Another example will help us illustrate further the distinction between thrust and pressure exerted by a body. Take a piece of foam and two identical metal blocks. Say M and N weighing 0.3 kg. The length, breadth, and thickness of these blocks are 0.3, 0.2, and 0.1 meters, respectively. Place the metal block M vertically and the other metal block N horizontally on the foam. Now, let's compare the compression of the foam where blocks M and N are placed. The foam shows more compression where the metal block M is positioned vertically. Considering that both the blocks have the same length, breadth, thickness, and weight, why do you think we see this difference in the compression of foam? This difference can be attributed to the difference in pressure exerted by each block. Block M was placed vertically over the sheet of foam, while block N was placed horizontally. The weight of blocks M and N being equal, the force exerted by the blocks on the foam was equal as well. But the surface area of contact for each block was different with the surface of the foam. The area of contact, that is, the surface area of a block, is the product of its length and breadth. Thus, the surface area of block M in touch with the foam is 0.02 square meters. On the other hand, the surface area of block N in touch with the foam is 0.06 square meters. Let's consider the value for acceleration due to gravity as 10 meters per second square. Using the formula for pressure, we can now calculate the pressure of blocks M and N on the foam. Here, thrust is the product of mass and acceleration due to gravity. The pressure of block M on the foam is 150 Newton per meter square. The pressure of block N on the foam is 50 Newton per meter square. Thus, in block M, the same thrust was acting on a smaller surface area. Hence, the pressure exerted by block M was higher. This explains why the foam showed more compression where block M was placed. The thrust exerted by a body remains constant placed in any position. However, the pressure exerted by the body changes if the surface area of contact of the body with another surface changes. Let's look at another everyday example. You may have used chairs in which the seat is created from plastic weave. These chairs are quite safe to sit on. However, if you try standing on such a chair, the plastic wire may give way under the pressure. This is because when you stand on the chair, the area of contact becomes much smaller and the pressure on the wire crosses the safety limit. In both the cases, the weight of the man, that is, the downward force acting on the chair, is the same. However, the surface area on which it is acting has changed, leading to change in pressure exerted on the seat of the chair. This brings